Hi, this is Jeff Heaton. This is my latest video on Kaggle competitions, and in this one I am going to show you how to do some tuning, hyperparameter tuning. You hear about this a lot in Kaggle. This is how you adjust all those various parameters that you can set for machine learning algorithms like XGBoost and like GBM and support vector machines. They all have these. Neural networks have their hidden layers, all this sort of thing. It's a different process, really, for each model type. And in this one, we're going to look not at, we'll do a little bit of grid searching, but we'll see how to use an actual strategy to try to optimize your XGBoost parameters. So this is part of the Kaggle playlist. Definitely check out the Kaggle playlist. If you are interested in more videos with Kaggle, definitely tell me in the comments. Click on like and subscribe to my channel. That definitely sends a message to me as far as what types of videos to actually produce. So in this video, we're going to focus on XGBoost. You hear a lot about XGBoost and other gradient boosting algorithms, now that there are other ones as well, and how to really optimize and tune your hyperparameters. Hyperparameter tuning is definitely one of the big topic points with Kaggle, along with ensembling and feature engineering. Personally, I feel feature engineering is king. That's really what's going to ultimately probably do this for you. Probably secondly is getting some good models together, as good a models as you can, and ensemble those together. So ensembling to me is second. Third would be hyperparameter tuning. I honestly in Kaggles do not spend a tremendous amount of time on hyperparameter tuning, but while I am trying to engineer new features and I have nothing better to do with my compute resources, I'll tend to run grid searches and other things to try to get those hyperparameters tuned on my existing models. The problem with hyperparameter tuning, though, is you don't want to necessarily do it that early, because if you change your features or change something significant to the input to your model, which is your features, then you probably have to retune. So be aware that the work and the compute time that you put into this may not have lasting value to you. Now, for XGBoost, I do have one script file in my Kaggle utilities that I have a link to GitHub in the description of this video. It uses a specific strategy, so it is not just doing this random big grid search. It does grid search, but it kind of does it pairwise on 2 parameters at a time, and comes up with a pretty good optimization typically. I found this doesn't give me a tremendous boost typically in the leaderboard, but it helps some. It definitely optimizes my XGBoost algorithms. XGBoost is kind of challenging because you've got 4 to 6 parameters that you're really optimizing, so that's a fairly high dimension space compared to like a support vector machine where you're optimizing 2. Neural networks are just an entire different ball game altogether, where you've got layers and neurons in layers. So for this video, we're going to focus on XGBoost using a specific algorithm that I found on the web, and I used to do this manually, so I just wrote script in Python around it to automate this process so that I don't have to do this manually, because I hate manual's monotonous. So this way I can essentially execute this off on a AWS instance somewhere in the background and not think about it. And of course, if you find this kind of thing interesting, please subscribe to my channel and click the little bell so that you're notified of any additional videos that I create. All of the code for this is contained on my Git repository, so definitely follow me or go to the repository and star it. You can just search for Jeff Heaton GitHub, you'll find it. I'll also have a link there. It's Jeff Heaton Kaggle Utilities. Go ahead and star and follow that to be up to date on all the latest changes to this. Because I evolved this. These are what I use when I do Kaggles and also other data science projects. So I typically start these videos by showing you where we're at in this whole process flow that I typically use for a Kaggle, showing you the file names of what I'm executing. I don't really show the tuning on here, but where we're basically at is right about here, between where you're tuning the individual models and sending it on to the ensemble. Now you can do tuning on both your models and also other external models that you've incorporated into your ensembles. We're going to focus really just on tuning your XGBoost models. Now the way that the script works is it is taking these pickle files. We generated these pickle files up here and then joined them together. So it's going to take the output from the joiner. And the output from that joiner then, this is very dependent on the features that you've engineered. So if you re-engineer your features, the changes you've made to your hyperparameters are probably not optimal anymore, and you might need to retrain your, I'm sorry, not retrain, but you might need to retune your model in that case. Now, you'll have many models potentially going into your ensemble. I just showed 2 here, but some of the high-end Kaggle entries have 50, 60, hundreds of these. So you might have many, many more here, but you're going to tune the individual models going into the ensemble. You can't really tune the ensemble itself. I mean, there are a few hyperparameters on the ensemble, but you won't tune that to the degree that you tune your XGBoost models, like we're going to talk about here. So let's switch to the code and take a look. And this is Microsoft VS Code. Normally, I'm not a Microsoft guy. You can see I'm running this on a Mac, but I really do like VS Code. If you want to see some videos specifically on VS Code, feel free to post a comment or 2. Really, you could be using PyCharm, you could be using just about any IDE. You can also run this in Jupyter. If you're trying to run this on Google Colab to get some free cloud compute time, you'll want to just copy this code and run it into the Jupyter Notebook. It might take a little bit of modification for Google Colab to actually know how to read the input files. If you want videos on Google Colab, definitely give me some comments on that too. We're going to use tune XGBoost. I just want to show you the structure of this file. Like I said, in other videos, these files are just meant as a starting point. You copy these and you go and you modify the config file. Look at one of the earlier videos to see how to modify the config file. The playlist puts everything in a nice order. And you can start to modify it. It's not meant to be a library that you just pip install and it just magically sort of starts winning Kaggle competitions for you, or even getting you into 10% of Kaggle competition. What this does is you want to look at near the top of this. Folds is how many cross-validated folds we're going to have. That differs from what you have in your config file. This will override what's in the config file because typically you'll want to do fewer folds on this because you're not really training a model here. You're just running, I mean, you are training models, but you're training a bunch of them to see what will give you the best parameters. So you want this to run quicker. It's going to take forever. So 5 is good. Max rounds. For XGBoost, this is the maximum number of rounds that this is going to train for. When you're doing this for real, I totally recommend doing 10,000 or so, just so that you're getting an accurate representation of how far this can train. Because this allows it to go up to 10,000 if early stopping doesn't stop it first. And when you train your model for real later, you're going to want to give it as many rounds as need be. So if you set this too low, it's going to think that all these models are not doing particularly well, and you just won't get an accurate estimate of what the hyperparameters should be. And by the way, hyperparameters, these are all of these configuration properties that you pass into something like an XGBoost. You need to give it, params1, an initial estimate of what you think the hyperparameters should be. Usually I don't put too many into here. I do start it often with a relatively low learning rate. You could start it even at a somewhat higher one, let it experiment with that. Seed just makes things consistent. You definitely need these two. These two won't be changed. Those are your base. It's a regression. And the evaluation is root mean square error. This is set up for the Kaggle Mercedes dataset. So you need to modify your config file and these just so that it's doing the right objectives for whatever type of model or Kaggle competition you're working towards. Here, that is the feature. I talked about that parameter in a number of the other videos. It's important if you just have one set of features, it's always going to be one, but sometimes you might want a different set of features for a neural network versus a different set for an XGBoost. Often you'll do different feature sets for neural networks. This lets you tell it which one you're actually dealing with. So this might all be one. I suggest these all be one initially. You create just one set of features just to get used to things and run with that. The initial parameters, I do tell it to run a single fold. You could have it do a 10-fold or 5-fold or whatever cross-validation you want to. This is setting it up very much just for a quick estimate. Just so that this is the kind of thing I typically run overnight or run for a day on a spare computer or an EC2 instance. I'm going to go ahead and set this really small. Don't set your max rounds to 5 because you'll just get a really superficial estimate of the hyperparameters. But for this video, that's going to make this actually run fast enough that we can really see some stuff. Further down in here, just ignore those. You'll probably leave most of those alone. This has several steps. Step 1, Step 2, Step 3, 4, 5, and then it's done. And at the end, it prints out the final set of hyperparameters for you, and you can basically just copy those over into Train XGBoost and train a real model on it. The way that this is set up, first of all, this can take a long time. So what I recommend doing, that's what these commented steps here are for. At the end, it's going to tell you what the results from Step 1 are. So it's going to print that. Step 1 takes a lot of time. So if you want to more focus on Step 2 and looking at things, you can basically comment out this and uncomment this and paste whatever it gave you for the outputs. Because Step 1 is figuring out max depth and max child weight. You can uncomment those and you can skip Step 1 then, because you don't want to rerun things constantly. So if you're debugging the code, you're making some enhancements to it, that can save you a lot of time. You can also just comment out all of this stuff and just run Step 1. So like I said, this is not just meant to be an off-the-shelf utility that you don't modify. This is a starting point. Now, let's have a look at what this is really trying to accomplish. I based all of this off of this other guy's article, which we'll take a look at now. In this tuning method is not my own. I am automating. So let's take a look at that real quick. This is a great article that I really like, that taught me a lot about XGBoost. I'll put a link to this as well. It's by Felix Revert. I hope I'm pronouncing that correctly. And it takes you through basically why you'd want to fine-tune and gives you a method. Now notice this. He has several steps here, and that's literally what my steps correspond to. He's telling you largely how to do this somewhat manually and giving you the code to actually make XGBoost set these parameters. But what I did is basically took this and somewhat automated it so that you're able to do all these various steps basically in code. So I took these correspond exactly to the steps that I have. So this is where I got it from. I just want to make sure I give credit where credit is due. And it looks like this is still pretty similar to, or still exactly the same as what I had. This is pretty recent. I mean, when I implemented it, I think it was pretty close to when he had published it back in 2018, which was only last year. Okay, let's look at some other things you might want to change. Notice how I am setting up these dictionaries. Max depth. So in Step 1, we're trying to optimize max depth, and I'm essentially doing pairwise. So I'm optimizing no more than 2 of these at once. That way you're optimizing a grid. If you start optimizing a cube or hypercube, look out. You're into serious computation time, and you may not be able to complete it. So what you'll see here is I'm using the Python range. This says that max depth, we are going to attempt to search over between 3 and 12 at a step size of 2. This range is probably decent for max depth. I don't see going more than 12 at the absolute most. But you might get some gain by looking at more values in here. You may want to make this 1 or 0.1 so that it steps through it at a much denser level rather than, because 2 is going to go 3, 5, 7, etc. Same thing with the range here. So you can, I think the ranges mostly that I have here are pretty reasonable, although feel free to mess with the ranges as well. And just about all of these work like this. I'm passing it to this grid search function that I wrote, the parameters, and then basically passing in this test, which is really giving it the range of values that you're looking at. Now, max depth, I'm not using a range. I am literally passing in the values. This, I think, is really pretty reasonable for this. So I'm taking whatever the max depth was from the previous one. So here, this is going according to Felix's strategy, which I find works quite well. He's going to narrow the depth. So now he's going to just look at just plus or minus a whole value. What is the depth? If I was going to tweak this and do more compute, I would get a little more granular and maybe do, instead of just -1 and +1, maybe minus 0.5. or maybe even tenths if I wanted to add considerable to this. And the rest of it, it just continues. Notice where here I use a comprehension to basically put in all the tenths between 0 and 5. So you'll want to modify these individual values as you go through. And that's pretty much it. It is going to use your first feature set that you generated, the 2 pickle files. Look at running the joiner earlier in the playlist for information on that. So now let's go ahead and run this and see what this does. I want to also show you too how this is working with multi-threading. I do not have this set up really good for multi-threading. This could benefit tremendously from using more multi-threading and also multi-machine. All right, things are happy. So I am going to expand this so that we can see the whole thing. It is now working on step 1. Starting job 1, 1 of 25. 1 means step 1. So it's going through that. It found 10 folds in the data set. So what it's doing there is basically, since we didn't ask it to cross-validate in this case, it is going to use essentially the first fold as the validation and the remaining as the training, and it's just going to do one thing. That's a way to do a quick estimate, less accurate, but again, since I don't want to spend a tremendous amount of compute time on this, I'm not going to be a prima donna and cross-validate every single thing just for a hyperparameter estimation. This is all about picking and choosing your battles for these kind of things. Now, you'll notice it's moving on to the second of 25 jobs from the first step. You also see that XGBoost only ran for 5 steps. Often debated. It's cranking right along. It's up to 8 of 25 on step 1, and it is continuing. I am going to go ahead and time-lapse this. And by the way, the result here, the 98 is the RMSE, which is not particularly good because we only did it for 5 steps. And it is essentially pushing each of these into a list so that it can evaluate each of these sets of hyperparameters at the end of the step, and it'll report on the best one. So let's fast forward until step 1 ends. Alrighty, step 1 just ended. See, 1 of 25, and at the end of each step, it's going to dump this. This is a list of all the jobs that it had for the step, and it's going to show you what the hyperparameters were and what the score was. Notice all the scores are the same. We're 5 is just not enough steps for XGBoost, but I'm trying to really just run this fast so that we can actually watch the program go through its motions. And it also shows you how many steps each took. So now it is at the end of step 1. This is important. At the end of each of these steps, it's going to show you the result. So these are what it found to be the maximum. So of all these ones here, this is the, I shouldn't say maximum. Use some error calculation methods. You want a minimum value, some you want a maximum value. So this is the optimal of all of those jobs that it tried. And this is what is then passed on to the next one. So notice the next training job 2. Remember I told you that it was going to basically just evaluate plus or minus 1 of the maximum depth. That's why there's only 3. There's the maximum depth itself, plus or minus 1. So really we wouldn't have to evaluate the maximum depth itself there, but just to make the program simple, I reevaluate it just so that maybe we need no change to the maximum depth. Maybe we don't need plus or minus 1 at all. But that checks the little area right around it. And then it continues on with step 2. Step 2 finish is pretty easy because there's only 3 jobs. And at the end, you have the same report, just like you had on step 1. And it says step 2 results. This is what you would copy and paste, is the result at the end of each of these steps. If you wanted to skip steps and basically override it, like I showed you earlier up in the code, you would basically just paste it into here and uncomment this, comment out the actual execution of the step, and that would show you, that would let you skip step 2 if you wanted to do that, and you were maybe optimizing some stuff in step 3 and you wanted to just rapidly get through step 1 and 2. I refer to these as jobs. They're not running concurrently. Let me show you something real quick. This is the activity monitor. It's actually, this is more just because we have such small parameters in here. This would be heavier typically, but we're at 91% idle, 86% idle. More threads would help this. You can also optimize XGBoost so that it uses more threads. Just look at how to do that in its documentation. Actually, the reason we're so idle is the program just shut down. It's done. But this is why I would like to make this multi-threaded, because this would make this program run a lot faster. All of those jobs are embarrassingly parallel. They could all be executed in parallel, and you could really optimize quickly, especially if you made this multi-machine and used a number of EC2 instances. Then it would be just how much money do you want to spend. The steps themselves, step 1, step 2, step 3, those are fences. You have to finish all of the jobs before you can move on to the next step. So you'd need some coordination there. That's definitely on my list of things to work on with this utility. Now, it looks like it just finished. I'm saying that because my fan shut down. Either crashed or it finished. Yay, it finished. So, if you look here, step 5 result. These are your hyperparameters that it recommends. Again, I set the max steps so small that these are probably not particularly good hyperparameters, but if you'd ran it overnight, these would be a great set. Now, what you can then do is copy those and go over here into train XGBoost. And by the way, this is why I have so many parameters commented out here. These are previous sets that I had worked on and maybe optimized. Some of them I will put comments to the right to say what I was doing. But what I would then do here is I would just create another set and call params equals and paste that right in there. And now you're good to go. So you have new optimized hyperparameters. You'd probably want to pull, it doesn't matter, but you'd probably want to pull these out because they're in the common set that we have up here that we concatenate together. But not absolutely required that you do that. Now you could actually do a full-blown train, generate a model output directory so that you can then ensemble this with the rest of everything else. Okay, that's how you optimize hyperparameters, or at least one of many ways that you can do this. I found that this works pretty well for me. If you want more Kaggle videos or other videos from me, definitely subscribe to the channel and click the little bell icon so that you're notified of every new change. Thank you for watching this video.